guys, how are you? So in today's session, we are going to talk about multiple linear regression. Why we are going to talk about the multiple linear regression? It is the case of a simple linear regression, where in simple linear regression we are providing a single input, single independent variable, and we get a variable of single dependent variable which is dependent on that independent variable. So, but here in the multiple linear regression, we have a case where we are provided with a single independent variable, and we have to provide the output, and we have to provide the output for the multiple dependent variable which are dependent on that single independent value. So here we get a multiple output just for a single input value. So let's start this multiple linear regression. And so far we have seen the concept of simple linear regression, where a single predictor variable x was used to model the response variable y. So we just see in I, I assume that you all know about simple linear regression, and we just see that we also know that for the value, when we provide the input value x, we get a response variable as y in the simple linear regression. Now in many applications there is more than one factor that influence the response. Multiple linear regression model thus describe how a single response variable y depends on linearly on number of predictor variables. Example, the selling price of a house can be depend on desirability of a location, the number of bedrooms, the number of bathrooms, the year the house was built, the square footage of the lot, and the number of other factors, the height. And the other example, you can say that height of a child can depends on the height of mother, height of father, nutrition, and the environment factors. So a single output can be depend on the multiple variables, and I think that in the starting I just say multiple independent variables are depend on single independent variables can be depend on multiple independent variables. That what is multivariant linear regression. Next game is formula and calculation for multiple linear regression. We have a single output where we have multiple inputs like x1, x2, and x3, and we have some constant values also, like where for k is equal to n is equal to n number of observations, and y output is dependent variable, xk is explanatory variables, the feature matrix, the features which we are going to provide. Beta 0 is y-intercept constant term, beta p the values that are beta 1, beta 2, and beta k. Slope coefficients for each explanatory variables. E, the model's error terms, we can also known as residuals, and sometimes this epsilon is also considered as zero because its value is very very small. So that's how you calculate the multiple regression. And multiple linear regression model with k predictor variables x1, x2 to xk, and response y can be written as this is the equation. That's what a linear regression look like. Here e is the residual terms for the model and can be considered as zero in some cases. The interpret the meaning of regression coefficients beta 0, beta 1, beta 2, beta k in this model. So we have to interpret the meaning of these coefficients, these beta 0, beta 1, beta 2 in this multiple linear regression model. Next example of this is the simplest multiple linear regression model for two predictor variables is y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus epsilon. And when we make a plot for this, when we make a graph for this, we can say that when we are considering the two variables, we have to we have to move on the 3D view, and where we have a single line on the 2D view, here we have a plane on the 3D view to get the output of a single variable. The surface that corresponds to the model y is equal to 50 plus 10 x1 plus 7 x2 looks like this. It is the plane in R3 with different slopes in x1 and x2 direction. So this is the simple example of multivariant multiple linear regression. Next is the multiple linear regression model is based on the following assumptions. There is a linear relationship between the dependent variables and the independent variables. So basically, we just assume these number of things while we are considering the multiple linear regression, that there is a linear relationship, not like a polynomial, not like a exponential. The independent variables are not too highly correlated with each other. The independent variables which we are using like x1, x2, and x3, the number of features which we are using for predicting a single value, those features are not correlated with each other. Let's say like my height is correlated with my brother height, but but we can't use these features as two features because these two features are correlated. So we have to try to figure out and try to take those features which are less correlated with each other. Observations are selected independently and randomly from the population, and residues should be normally distributed with a mean of 0 O and variance sigma. So these are the assumptions for the multiple linear regression. And next comes the difference between linear and multiple regression. So in linear regression, ordinary least squares OLS regression compares the response of a dependent variable given a chance in symbol explanatory variables, given a change in in some explanatory variables. However, it is rare that a dependent variable is explained by only one variable. So basically, in real world, it is very difficult. Like predicting a house value is difficult that it is difficult that predicting a house value based on a single feature like number of bedrooms. How a house price is also depend on the area and the quality of the house. Like is house is fully decorated or not, and full furnished or not. And there are and there are other cases too, and other factors to consider the house price. Next is multiple regressions can be linear and non-linear. Multiple regressions are based on the assumption that there is a linear relationship between both the dependent and independent variables. It also assumes no major correlation between the independent variables. So it also assumes that there is no correlation between the features of the all independent variables. And that's all the about the difference between linear multiple regression and linear and the multiple regression. So I hope you basically understand this about the multiple linear regression. It is not much that difficult, and it is very easy to understand. Like if you are sorry, if you are like when you are when you are predicting a blood pressure of a person, you can't just predict a blood pressure of a person based on the just age number. You have to also consider its height, its the person's diet, what the diet person takes, and did person working out every day or not, the what is the lifestyle of that person, and what is the like person's genes or DNA. Like if the mother and father of that person having the blood pressure issue, then there is also a high chance that that person also having a issue of blood pressure. So there are many factors on which a single value can be evaluated. So multiple linear regression is very important, and you can't evaluate a single value based on a just single value. To predict a single value, you need a multiple features to predict that value. So you are thinking where this multiple linear regression is used. So I hope I just make your mind clear that where we use the multiple linear regression while when we have multiple features and we have to predict one value, there we gonna use this multiple linear regression. So that's all about this multiple linear regression. I hope I clear your all doubts. And that's all for the today's session. Thank you. Bye. Take care. Stay motivated and keep learning.